In this video, I introduce a nearest neighbor contrastive learning of visual representations. Self-supervised learning based on instance discrimination trains encoders to be invariant to different views of the same image. Nearest neighbor contrastive learning of visual representations samples the nearest neighbors from the dataset as the positives. NNCLR uses the nearest neighbor clustering to find the similarities across items within previously seen examples, namely the nearest neighboring are used as a positive in contrastive loss to improve the performance of the self-supervised learning. As shown here, this is the architecture of nearest neighbor contrastive learning. This input image, this view 1, this view 2. This encoder. We use contrastive loss to train the model. And this is the nearest neighbors generated from the support set. If NCE loss is used in the instant discrimination, given sample embedding Zi is a positive counterpart, Zi plus, and many negative embeddings, Z minus. The info NCE loss is defined as here and explained in this figure, where tau is a softmax temperature. Same CLR uses two views of the same image as the positive pair, which are randomly produced using random data augmentations, and then fed into encoders to obtain the positive embedding pair Zi and Zi plus. For example, given a mini batch of images from x1 to xn, two different random augmentations of each image xi are generated from the encoder file as shown here. Where aug is a random augmentation function, the same CLR loss on a sample I is defined as here and explained in this figure, this input image, this view 1 and this view 2. We use the same CLR loss to train the model. Each embedding is L2 normalized before the dot product is computed. The final same CLR loss over a mini batch is defined as here. However, it cannot link multiple samples potentially and belong to the same thematic class. NNCLR uses nearest neighbor clustering to obtain diverse positive pairs, which uses Zi's nearest neighbor in the support set Q to form the positive pair. The NNCLR loss on a sample I is defined as here and explained in this figure. This input image, this view 1, this view 2, this encoder. This support set Q. We use nearest neighbor clustering from this Z to get this Q, and then we use info NEC loss to train the model. Where NN is the nearest operator, the final NNCLR loss is defined as average over the mini batch as shown here, which is minimized to train the self-supervised models. For more details, please check with these references. Thank you. Bye.